week on WDD's HotSpot, a new microfluidic chip from NIST produces and detects a specialized gas used in biomedical analysis and medical imaging. It produces polarized or magnetized xenon gas and then detects magnetic signals from the gas. Polarized xenon can be dissolved in liquids and used to detect the presence of certain molecules. A chemical interaction with target molecules subtly alters the magnetic signal from the xenon. By detecting this change, researchers can identify the molecules in a complex mixture. Polarized xenon is also used as a contrast agent to enhance images in experimental magnetic resonance imaging, or MRI, of human lungs. But conventional systems for producing and using this gas can be as big as a car. The new chip has the potential to reduce the size and cost of some instruments that, like MRI, rely on nuclear magnetic resonance, or NMR. The chip's sensitive internal detector boosts the response of microfluidic NMR on small samples and eliminates the need for the powerful magnets associated with larger NMR devices such as those used in MRI. For more information, visit the link below. London-based Bear Conductive has raised over $200,000 from a Kickstarter campaign last year for their touch board that turns any conductive material into a potential capacitive touch input. Based around an Arduino Leonardo board, the touch board features an MP3 player, MIDI device, a micro SD card socket, 3.5mm audio jack, and a custom chip that allows the touch board to act as a capacitive sensor. For more information, visit the link below. Researchers from the Massachusetts Institute of Technology, or MIT, Lincoln Laboratory, and NASA have demonstrated a data communication technology that can provide space dwellers with the connectivity we all enjoy right here on Earth, enabling a large data transfer and even high-definition video streaming. Because who wouldn't want to watch YouTube in space? I mean, come on. They like HotSpot up there too.
Houston here. Roll for HotSpot, over.
The team made history last year when their Lunar Laser Communication Demonstration, or LLCD, transmitted data over 384,633 kilometers between the Moon and Earth at a download rate of 622 megabits per second, faster than any radio frequency system. They also transmitted data from the Earth to the Moon at 19.44 megabits per second, a factor of 4,800 times faster than the best RF uplink ever used. That's pretty darn impressive. For more information, visit the link below. And finally, early this year, Google unveiled its Project Tango smartphone, a mobile device equipped with a depth sensor, a motion tracking camera, and 2 vision processors that let the phone track its position in space and create 3D maps in real time, making it useful for robots which have to navigate and locate themselves in the world. Well, researchers at the University of Pennsylvania have taken their Tango device and strapped it onto one of their quad rotors and let it loose inside their lab. One of the biggest challenges for researchers working with flying robots is developing hardware and software capable of making them autonomous. But the Tango phone opens the door for new possibilities with its ability to localize itself in space without GPS or external sensors. According to the researchers at Pennsylvania, the convergence of computation, communication, and consumers has a huge potential for the robotics industry, and a device like Tango is a key advance because it's lowering the barrier to entry for autonomous robots. For more information, visit the links below. Well, that's all for this week. For more wireless news, go to wirelessdesignmag.com. Don't forget to follow us on Twitter and like us on Facebook. For WDD, I'm Megan Zimba, and I'll see you next time in the HotSpot. Yep, that was a lot of information.